Hello, this is Joe Reagan. Today I'd like to show you how to do 2D kinematic analysis with SolidWorks using 2D geometry known as blocks to represent linkages. First, we'll create a new file. It needs to be an assembly file since we're going to do motion analysis. Once in the assembly file, let's give it a file name. I'll call it kinematic. Once the file is saved, create a layout, and let's choose a view that's normal to this layout sketch. Now I'll create some two-dimensional geometry that will represent our linkages. This will be the long linkage. This will be the short linkage. And this will be the fixed linkage. Okay, I'll put circles at the end of the short and long linkages just to make the motion a little bit more apparent. Adding these circles is cosmetic and unnecessary. Okay, I'll add relationships to the circles, making their diameters equal, and then a dimension to drive the dimension down to 1/8 of an inch in diameter, and then similarly on these other circles, make their diameters equal. Okay, now I'll add smart dimensions to control the length of the linkages. I'll let this linkage be 2 inches long and define the other linkage to be let's let it be 1 inch long, and then the fixed linkage will be assigned to be 0.5 inches. And now I'll right click and select the midpoint of the short linkage, control select the origin, and set that to coincident. And then just for certainty, we will add an anchor to that fixed element to make sure it's fixed and will not move during the motion analysis. Okay, this geometry needs to be converted into blocks, so I'll select the elements, right click, make it a block. Check. Now I'll name this long, so that will be my long block. And then similar operation on this guy. Right click, make block, check, and then rename the block to short. And then the last one, right click, make block, check, fixed. Now I will add relationships so the linkages are connected to each other. So the endpoint of the long linkage and the endpoint of the fixed linkage will be coincident, and the other endpoint of the fixed and one of the endpoints of the short will be coincident. The other endpoint of the short and the entire line representing the long linkage will be selected, and we'll define that as coincident. And once those relationships are added, you can move your model to experiment with it and notice that the fixed linkage is spinning about the origin. We do not want that, so we'll undo that drag and then zoom in a bit, click on that linkage, and we'll make it horizontal, and we'll just fix it for good measure. Okay, now I select my geometry and spin around, and I confirm that I have the relationships that I want that will properly constrain the model. Now that we've confirmed that our relationships are in order, I will return from the sketch layout, from the assembly layout, and then I'll go to Office Products, turn SolidWorks Motion on, go to the Motion Study, that should be a tab down at the bottom, and then let's change the type of motion study to motion analysis. That's the most advanced motion study SolidWorks offers. And once we've done that, you see we can add gravity, we can add contact relationships, we can add forces, dampers, springs, motors, all these types of elements that you might need for a particular motion analysis. In this case, we're just going to have a fixed RPM motor driving the long linkage. So I'll click on motor. Now this is where it's handy that we named our linkages, because I want to apply the relationship to this long linkage. Okay, right now SolidWorks is wanting to know what should it spin with this motor. And so I'll go down to this endpoint and I'll right click and hit select other. Now I'm looking for the endpoint of the long block, so that's this one. So I'll click on that and we'll let it turn counterclockwise. I'll slow the speed down to 10 RPMs and accept that. And now we can run this analysis. See that it behaves properly. I'm going to reset the analysis, and now we're going to track the velocity of this point. So I'll click on results and plots, and I want displacement and velocity, and then under the subcategory I want linear velocity, and I want the magnitude. And now I'll select the point I'm interested in, that's this point, and check, and it computes it for those 4 seconds. Now I can drag my timeline out and go and recompute. Remember, when you make changes to the model, you should always recalculate. So I'm running the model longer, I had to recalculate, and there it is. So it ran the model for those 10 seconds and produced the plot for the velocity of that point of interest. Now we can also turn gravity on using this button, and in order to control the in order to do that type of motion analysis, you of course need to be able to control or assign the mass of the linkages. So since these are created as blocks, you can give any block a mass property. So currently this long block, which I have selected, has a mass of 5 times 10 to the minus 5 pounds. You might want that to be, I don't know, 1 pound. Okay, and you might want to check out the center of mass. Let's see, where's the center of mass? They have it located down here. Maybe you wanted it at the end point, or maybe you wanted it at the midpoint. Let's change it. Let's put it at the midpoint. there. Okay, I can check that. And we can return from the layout and go up and reset our model. I could delete the motor if I wanted to, and turn gravity on, and I want gravity in the Y direction. Check. I'm going to close this plot. I want to simulate it a bit longer, and we'll recalculate. Now what just happened? So far so good. Uh-oh. Too much error built up in the integrator, and the mass started swinging all the way over the top. Okay, so in order to address this problem, we need to go into the properties, and we need to go into advanced options, and we're going to change the size of our integration step. Okay, I'm going to decrease the size of the integration step by a factor of 10 in all cases, and hit OK and check. Now let's recompute the model and see if it behaves more appropriately. So you can see by decreasing the integration step size and increasing the frame rate for the video capture, we've made the model nice and smooth with gravity driving the system. Thank you.